This is the Edexcel Paper 3 higher tier from June 2024. The first question, find the highest common factor of 63 and 105. So to do this, we need to write them as a product of their prime factors. So we can use the calculator. I'm going to do it without a calculator. So 63 is 3 lots of 21. 21 is 3 sevens. So 63 can be written as 3 times 3 times 7. 105 is 3 35s, which is 5 sevens. So 105 can be written as 3 times 5 times 7. I'll show you that on the calculator. So if I type in 63, if you've got a fact button, shift fact, and it changes it to a product of its prime factors. Now we need to work out what they've got in common. Let's do a quick Venn diagram. So 63 and 105 in common, we've got a 3 and a 7. 63's got a number 3, 105's got a 5. So what they got in common, the 3 and the 7. So it's 3 times 7 is the highest common factor, 21. Question 2, standard form. So write 5.3 times 10 to the power of 4 as an ordinary number. It's 5.3 times 10 4 times. So times 10 once, 2, 3, 4. We can use the calculator again. So with standard form, either the question, if I type in the question to the calculator, it's going to give me the answer. Or if it doesn't work, if I type in the answer, it will go back to the question. So if I type in 5.3 times 10 to the power of 4, I get 53,000. Write 7.4 times 10 to the power of negative 5 as an ordinary number. So it's 7.4 divided by 10, 5 times. So there's a 0, and then a point, and then 4 zeros, and then 7, 4. So in total there's 5 zeros, and it's a power of negative 5. Again, check on the calculator. So if I type in 0.1234 zeros, 7, 4, it's going to take me to 7.4 times 10 to the power of negative 5. Calculate the value of 9.7 times 10 to the power of 6 plus 2.45 times 10 to the power of 7. Give your answer in standard form. I am just going to type it into the calculator, and it's probably going to give me an answer not in standard form, and then I'll just convert it. So 9.7 times 10 to the power of 6 plus 2.45 times 10 to the power of 7, and we get 34,200,000. So we need to write that in standard form. It's going to be a number between 1 and 10, which is 3.42 times 10 how many times? So it's 1, 2, 3, 4, 5, 6, 7 times. And again, check it on the calculator. So if I type in the answer, it's going to go back to 34,200,000. So 3.42 times 10 to the power of 7. And there we have it. Question 3. The diagram shows a solid triangular prism. Raina is trying to draw the side elevation of the solid prism from the direction of the arrow. Here is her answer on a centimeter grid. So it should be 7 wide, which it is, but 4 is the slanted height. So Rainer's side elevation is not correct because the perpendicular height is not 4 centimeters. It should be less. So the perpendicular height is this height. 4 centimeters is the slanted height. And on the centimeter grid, draw a plan of the solid prism. So a plan is the view from the sky, the view from the top down. So it's going to be 6 by 7, a 6 by 7 rectangle with a straight line down the middle for the peak, the apex, the top. So let's draw it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. A straight line down the middle. Like so. Question 4. A company has 25,000 workers. The number of workers increases at a rate of 6% per year for 3 years. Calculate the number of workers at the end of 3 years. So it's like a compound interest question. We're adding on 6%. So after each year, we're going to get 100% plus 6%. And as a decimal, that's 1.06. So to add on 6% in one calculation, we times by 1.06. We need to do that 3 times. So it's cubed. And we're just going to type that into the calculator. 25,000 times 1.06 cubed. 29,775. I'm going to give it as a whole number because it's a number of people. So to the nearest whole number, 29,775. Question 5. Habib has 2 identical tins. He puts 600 grams of flour into one of the tins. The flour fills the tin completely. The density of the flour is 0.6 grams per centimeter cubed. So we've got density, mass and volume. Density is equal to mass divided by volume. And we know the mass and the density, so we can work out volume. So 0.6 equals 600 divided by V. So V is going to be 1,000. 600 divided by 1,000 makes 0.6 centimeters cubed. So that's the volume of a tin. Habib puts 600 grams of salt in the other tin. So that's mass again. The salt does not fill the tin. The volume of space not filled is 700. So not filled is 700. So filled is 1,000 take away 700, which is 300. So that's the volume of the salt. We've got the mass of the salt. And the question, work out density. So density is mass divided by volume. 600 divided by 300, 2 grams per centimeter cubed. Tim has 2 bias coins, A and B. He's going to throw both coins. The probability that coin A will land on heads is 0.6. So not heads, 1 minus 0.6, 0.4. The probability of B landing on heads, 0.55. So not heads is 1 minus 0.55, 0.45. And this is coin B as well. We just need to write it out again. Tim throws coin A once and coin B once. work out the probability that both coins land on heads. Heads, then heads. When we go across the branch, we times. So the probability of heads is 0.6 times 0.55. And we get 0.33. A paddling pool is in the shape of a cylinder. We've got a radius of 100, depth of 30. We can see that on the diagram. It's empty and filled with water at a rate of 250 centimeters cubed per second. Work out the number of minutes it takes to fill the pool completely, filling it all the way to the top. Give your answer to the nearest minute. So we need to work out the volume of the cylinder. And the volume is the area of the cross-section, area of the circle, pi r squared times the height, times h. So pi times 100 squared times 30 is going to be the volume of our pool. So pi times 100 squared times 30. So I've got 300,000 pi. 300,000 pi. I'm going to leave it in terms of pi for now, just because it's easier to write down. It doesn't matter if we change it. So that's how many centimeters cubed we've got. And then 250 centimeters cubed per second. So how many seconds? Divide it by 250. That will tell us how many seconds. So answer over 250, 1,200 pi or 3,770 seconds. But we need to know how many minutes to the nearest minute. So change seconds into minutes. Every minute is 60 seconds. So divide by 60, 20 pi or 63 minutes to the nearest minute. Question 8. A is 3 right, 2 up. B is 1 left, 4 up. On the grid below, draw and label 2 A's plus a B. So if we go 2 A's is going to be 6 to the right and 4 up. And so 2 A's plus a B is going to be 5 to the right and 8 up. So 2A plus B is 5 to the right and 8 up. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So 2A plus B is 1, 2, 3, 4, 5 to the right, 1, 2, 3, 4, 5, 6, 7, 8 up. Question 9. The diagram shows a cube and a square-based pyramid. The volume of the cube is equal to the volume of the pyramid. Work out the height of the pyramid. So the volume of a cube. So for the cube, the volume is just length times width times depth. 6 times 6 times 6. Let's just check that on the calculator. 216 centimeters cubed. For a pyramid, whenever any shape goes to a point, like a cone or a pyramid, the volume is 1/3 of the prism. 1/3 of if it was a cuboid. So 1/3 of this shape. So for the pyramid, the volume is 1/3 of 8 times 8 times h. So that is going to be 64 over 3 h centimeters cubed. So they're equal, so we can say 216 is equal to 64 over 3 h. So then we just need to solve. So times by 3, divide by 64. So 216 times 3, divide by 64. H is 81 over 8, or 10.125. Question 10. There are only red counters and yellow counters in bag A. The number of red to the number of yellow counters is the ratio 3 to 5. There are only green counters and blue counters in bag B. The number of counters in bag B is half the number of counters in bag A. Given that there are X red counters in bag A, use algebra to show the total number of counters in A and B is 4x. So red is X, so X red counters. So if X is 3 parts, X is 3 parts, just draw this. So 3, you don't have to draw it, and 5. So if X, all of these are X, each one must be a third of X. X divided by 3. So how many yellows are there? In terms of X, we've got 5 thirds of X. So for yellow, we've got 5 thirds X. 5 thirds X are yellow. So the total for bag A, so bag A is X plus 5 thirds of X. So 1 plus 5 thirds is 8 thirds. So it's 8 thirds of X in total. Bag B is half of bag A. So bag B, bag A is 8 thirds X. 8 thirds X halved is 4 thirds X. So what do we have in total? We've got 8 thirds X plus 4 thirds X, which is 12 thirds of X, which is 12 thirds 4x. So there's 4x counters in total. Question 11. Mina records the speeds in miles per hour of some cars on a road on Friday. She uses her results to work out the information on the table. So we've got lowest, lower quartile, median, interquartile range, and range. And we're going to draw a box plot. So we don't want to know the interquartile range, we want to know the upper quartile. So the lower quartile plus the interquartile range is 47, so that's the upper quartile, and the lowest speed plus the range will be the highest speed. So 37 and 25 will make 62. So now we know all the information. The lowest speed we draw on with a line, and the highest speed we draw on with a line. The lower quartile, the median, and the upper quartile, they all get a line. We connect the quartiles up with a box, then we draw these whiskery things out to the highest and the lowest. So there's our box plot. Mina also records the speeds of some cars on Sunday. She uses her results to draw this box plot. Compare the distribution of the speeds on Friday with the distribution of the speeds on Sunday. So we need to compare the spread and the average. So let's compare the median for the average. So the median speed on Sunday was higher. We need to give our answer in context. So we need to mention speed. So the median speed is good enough to do that. So the median speed was higher on Sunday. So we've compared the average, we've given it in context because we wrote speed. And then let's compare the range. We can see that the range and the interquartile range, both of them were higher on Sunday. So you can see that the box is wider on Sunday, so the interquartile range is bigger. So the interquartile range of the speeds was higher, was greater on Sunday too. The speeds were more spread out. There was a greater range of speeds on Sunday. Question 12. The diagram shows triangle T drawn on the grid. Enlarge triangle T by scale factor -2, center of enlargement at the origin. So here's our center of enlargement. To go to the bottom corner, we go along 1 up 2. So along 1 up 2. If we times that by -2, how far do we have to go? Back 2, down 4. So it's going to be back 2, down 4. Take another point, along 3 up 2. Times it by -2. That would be back 6, down 4. So back 6, down 4. And another point, along 1 up 3. Times it by -2 will be back 2, down 6. Back 2, down 6. And we're just going to join them up. And that is our enlargement. Question 13. There are 30 students in a class. A teacher is going to choose at random 2 of the students. Work out the number of different pairs of students the teacher can choose. So for the first pick, there are 30 options. So once we've picked one person, how many are left? There are 29 people that can go with them. So it's 30 times 29. So the only problem with this is we're going to have double counted. So picking student A first and then student B, or picking student B first and then student A, it's going to end up with the same pair. So we're going to have twice as many pairs as we should because they're all going to be doubles. So half the answer. Let me show you that with like 3 students. So if there's 3 students, A, B, and C, we could pick 3 options for first. And then once we've picked one, there's 2 options for the second pick. So we could say there's 6 options. But what are those 6 options? It's A, B, AC, BA, BC, and CA, CB. They're the 6 options. But you can see we've got doubles. A and B is the same as B then A. A then C is the same as C then A. And B and C is the same as C then B. So we've got a half it to tell you how many different options we've got. So we've got 30 times 29 over 2. 30 times 29 over 2. That's 435 different options. Question 14. At the start of 2022, Kim invested some money in a savings account. The account paid 3.5% compound interest each year. At the end of 2022, interest was added, then Kim took 750 out. At the end of 2023, interest was added, and then Kim took 1,000 out, there was then £2,937.14 in the account. Work out how much money Kim invested at the start. So let's try and write down what happened. We're going to start with X. Then we're going to add on, so times 1.035, add on 3.5%. Then we're going to take £750 out. And then we're going to get interest again. So then it's that times 1.035%. And then we're going to take out again £1,000. And then we're left with £2,937.14. We're going to have to undo this, kind of do it backwards. So let's start by adding on this 1,000, so we can get rid of that. So £2,937.14 plus on the 1,000 is £3,937.14. So X times 1.035 minus 750 times by 1.035 is £3,937.14. So now we want to take off that 3.5%. To get rid of a times by 1.035, we divide by 1.035. So to go backwards, divide by 1.035. £3,804. So X times 1.035 minus 750 is £3,804. We want to add the 750 back. So plus 750, 4,554. So X times 1.035 is £4,554. And then divide by 1.035 again. Divide by 1.035 and we get £4,400. Question 15, simplify fully. We have a minus 3 squared on top, 5 times a minus 3 on the bottom. This is the same as if we had x squared over 5x. It's just that our thing we've got in common to the top and the bottom is a minus 3. So for x squared over 5x, we would divide top and bottom by x. For a minus 3 squared over 5 times a minus 3, we're dividing top and bottom by a minus 3. Part B, factorize. So we are going to put this into double brackets. I'm going to do a times c. 3 negative 4s make negative 12. What multiplies to make 12? We can have 1 12, 2 6s, 3 4s. How can I make an 11 out of them? It's going to be 12 take away 1. So I'm going to change it into 3k squared plus 12k minus 1k minus 4. I'm changing 11k into 12k minus 1k. When we expand double brackets, we get 4 terms, and then we add the middle ones together. We collect the like terms. I've split the middle term back up into 2 separate terms, and then we can work out what the multiplications were. So what can I take out of 3k squared and 12k? What comes out of the first 2 terms? 3k, and then 3k times what makes 3k squared? That's k. 3k times what makes 12k, plus 4. Something times k is negative k, that's negative 1. And negative 1 times positive 4 is negative 4. So I've got 3k minus 1 times k plus 4. Question part C, simplify fully. So we're going to have to factorize what we can, change our divide to a times. 4 minus x squared is the difference of two squares. It's 2 plus x times 2 minus x. X squared plus 3x, I can take an x out of, so it's x times x plus 3. So I factorize the top and the bottom. To change a dividing fractions to timesing fractions, we flip over the second fraction. So dividing by x plus 2 over x plus 3 is the same as timesing by x plus 3 over x plus 2. When we multiply fractions, we just times the top times the bottom. So I'm going to write it as a single fraction, 2 plus x times 2 minus x times x plus 3 over x times x plus 3 times x plus 2. Cancel out the like terms. X plus 3 is on the top and the bottom, and x plus 2 and 2 plus x are the same thing. So we just get 2 minus x over x. Question 16. Functions f and g are given. So f of x is 12 over x plus 1. G of x is 5 minus 3x. Find f of negative 3. So this just means change x into negative 3. F of negative 3 is 12 over negative 3 plus 1. 12 over negative 3 plus 1 is negative 6. Find fg of 1. So we put 1 into g and then put that answer into f. So g of 1 is 5 minus 3 ones, which is 2. Now we're going to put that into f. So we want f of 2, which is 12 over 2 plus 1. 12 over 3, that's 4. Find g minus 1, so the inverse of g. G minus 1 of x, the inverse function of x, does the opposite. So the output becomes the input, and the input becomes the output. So if there's a function g, you have an input, you put it into g, and you get out the output. G minus 1 of x is the opposite. So you get the output, you put it into the opposite function, and it takes you back to the input. It does the opposite thing. Instead of going from left to right, it goes from right to left. So our g function is 5 minus 3x. We could work out what the inverse function is and then put 4 into it. Or we could say, what do you have to put in to g to get out 4? So it's 5 minus 3x equals 4. Plus 3x to both sides. Take away 4 from both sides and divide by 3. X is 1/3. So it should be 1/3. I'm going to just work out the inverse function as well, just to show you. So g of x is 5 minus 3x. G of x is 5 minus 3x. So what is the g function? We times by negative 3 and then plus on 5. So the function is timesing by negative 3 and then plussing 5. So you have the input, you times by negative 3 plus 5, and you get the output. So what is g minus 1 of x? So you'll start with the output and you'll work backwards. So you'll have to take away 5. So it's going to be take away 5, and then instead of timesing by negative 3, we're going to divide by negative 3. So that's the opposite function. If we put 4 into the opposite function, g minus 1 of 4, it'll be 4 minus 5 divided by negative 3. So negative 1 divided by negative 3, 1/3. Question 17. A ball is thrown upwards and reaches a maximum height. The ball then falls and bounces repeatedly. After the nth bounce, the ball reaches a height of hn. After the next bounce, the ball reaches a height given by hn plus 1 is 0.55 times hn. So each bounce is 55% of the bounce before. So it's bouncing lower every time. After the first bounce, we have 8 meters. What height does the ball reach after the fourth bounce? So the second bounce is 0.55 times 8, which is 4.4 meters. The third bounce is the answer times 0.55. (2.42), and fourth, answer times 0.55 again, 1.331 meters. ABCD is a quadrilateral. The area of ABC is 54 centimeters squared. Calculate the area of ACD. So we're going to use half AB sine C to find this length. Let's just call it little b. So half AB sine C, find that length. Half. So half AB sine C. C is the angle. So this is the angle. The other two, the two next to it, little a and little b, in any order. So it's half times 17 times b sine 35 equals 54. Let's just divide by half times 17 times sine 35 and get b by itself. So 54 over half times 17 times sine 35. And we can just type that into the calculator. So we have 54 over half times 17 times sine 35, 11.076, and so on. So now we know that length, 11.076. We are going to need to find another length. So we're going to use opposites. So let's find this length up here. I'll call it x. So sine rule, when we've got opposites, we're using the sine rule. So it's going to be x over sine 48 is equal to 11.076, our last answer, over sine 57. So to get x by itself, I'm going to times by sine 48. So just type it in the calculator again. So we have our last answer over sine 57 times sine 48, 9.8144. So that's our other length, 9.8144. I should have saved these in the calculator. Let's store that one as A. Hopefully I'll go back, store that one as No, that's not right. Go back and store that one as B. So I've got these saved as A and B now. For the area of a triangle, half AB sine C, we need the angle and two lengths next to it. So at the moment, we've got our 9.8144 at our 11.076, but the angle in between them, we don't know, but we can use the angles in the triangle, add up to 180. So 180, take away 48 and 57 is 75. So it's 75 degrees. Now we can use half AB sine C. So it's half times the 11.076 times the 9.8144, half AB sine C. So that is the area of the triangle. So it's half times A times B sine 75. And A and B are the ones we saved in the calculator. We get 52.5 degrees. No, 52.5 centimeters squared. Question 19. R is equal to P over Q. P is 5.88 times 10 to the power of 8. Correct the three significant figures. So it's going to be bounds. Q is 3.6 times 10 to the power of 5. Correct the two significant figures. Work out the lower bound for R. So the lower bound for R, if we want the smallest possible answer, we're going to get the lower P divided by the upper Q. To get a smaller answer, we divide by a bigger number. So what is the upper and lower bounds? So for P, we've got 5.88 times 10 to the 8. The one below will be 5.87 times 10 to the 8. The one up will be 5.89 times 10 to the 8. So the midpoints are 5.875 times 10 to the power of 8 and 5.885 times 10 to the power of 8. For Q, we've got 3.6. The one down's 3.5. The one's up is 3.7. So the middle's 3.55, and it's times 10 to the power of 5, and 3.65 times 10 to the power of 5. So the lower bound for P is 5.875 times 10 to the power of 8. The upper bound for Q, 3.65 times 10 to the power of 5. So let's just type it into the calculator. 5.875 times 10 to the power of 8 over 3.65 times 10 to the power of 5. And we get, give your answer as an ordinary number, correct to the nearest integer. So we're going to round up 1,610. Question 20. X minus 4, x plus 2, and 3x plus 1 are three consecutive terms of an arithmetic sequence. So it goes up by the same thing every time. It's got a common difference. It's like 3, 8, 13, 18, and so on. It goes up by the same thing every time. Find the value of x. So what does it go up by every time? Well, between the first two terms, it goes up by 6. X minus 4 to x plus 2 is 6. Or x plus 2 take away x minus 4 is 6. So the difference between the two terms must be 6. So x plus 2 plus 6 must equal 3x plus 1. If we add 6 on, we must get the next term. So x plus 8 is 3x plus 1. Take away x from both sides. Take away 1 from both sides. And half both sides. X is 3.5. 3.5. 7 over 2. Part B, I'm actually re-recording this because I made a mistake with the factorising. Hopefully I will get it right this time. We have 3 consecutive terms of a geometric sequence this time. When we've got a geometric sequence, it means there's a common ratio. So we multiply by the same thing every time. So if the first term was 2 and the common ratio was 3, to get from one term to the next, we times by 3. So it'd be 2, then 6, then 18, and then 18 times 3, which is 54, and then 54 times 3, and so on. So you multiply by the same thing every time. So the first term times something, y minus 4 times something, some number, is equal to y plus 2. And y plus 2 times something, the same something, is 3y plus 1. So to get from one term to the next, you times by some number. So we've got 2 equations here. If I divide both sides by the thing multiplied by the ratio, so y minus 4, and divide both sides by y plus 2, I've got 2 things equal to r, and I can make them equal to each other. So y plus 2 divided by y minus 4 must be equal to 3y plus 1 over y plus 2. I now need to solve this equation, so I'm going to get rid of the fractions by timesing. So times both sides by y plus 2, and times both sides by y minus 4. So I've got rid of the fractions. I now just need to expand the brackets and make it equal to 0. And then I'll have my quadratic to solve. So expand the brackets, y times y is y squared, y times 2 is 2y, 2 times y is 2y, and 2 2's are 4. 3y times y is 3y squared, 3y times negative 4, negative 12y, 1y is y, and 1 negative 4 is negative 4. So we've got y squared plus 4y plus 4 is equal to 3y squared minus 11y minus 4. I'm going to make it equal to 0. I'm going to have my y squared as positive, so I'm going to move everything over to the right. So take away y squared from both sides, take away 4y from both sides, and take away 4 from both sides. So I've got my quadratic to solve. I'm going to solve it by factorising. We can use the calculator, we can use the quadratic formula, but I'm going to factorise it. I'm going to do a times c, 2 8s or 2 negative 8s, 16. What multiplies to make 16? 1 16, 2 8s, and 4 4s. How can I make a negative 15 from that? So I'm going to have 2y squared. I'm going to change negative 15y into negative 16y plus 1y. Now I am going to put them into brackets. So what can I take out of the first 2 terms? What can I factorise out of 2y squared minus 16y? It's 2y. 2y times something is 2y squared, that's y. 2y times negative 8 will be negative 16y, plus 1 times y is y, and 1 times negative 8 is negative 8. So it's factorised. I now just have to give my answers. So y could be minus a half, and y could be 8. So it's minus a half, or 8. And you can see from the question, it said find the possible values of y. So there's 2 answers, 2 possible answers. It could either be minus a half or 8. And that's it. Question 21. This is the last question. The diagram shows a circle, radius r centimeters, and two regular hexagons. Each side of the larger hexagon, A, B, C, D, E, F, is a tangent to the circle. Each side of the smaller hexagon, P, Q, R, S, T, U, is a chord of the circle. By considering perimeters, okay, so that pi is between 3 and 2 root 3. Okay, so let's mark on the center of our circle. We know the radius is r. So this is a radius, this is a radius, this is a radius, and so on. So let's call this r. So a hexagon can be split into equilateral triangles. So we've got 60 degrees. So we've got 6 triangles. The whole way around the point is 360. So these are 60-degree angles. And we also know the interior angle of a hexagon is 120. So these are 60s as well. So we've got another radius here. So it's RR and R. So the small hexagon has a perimeter of 6 R's. 6 radiuses make the perimeter. How about the large one? How can we work out the perimeter of the large hexagon? So we are going to have to do something with this triangle here. So again, I've just drawn on another radius of the circle. So we've got a radius here. That's a radius as well. Again, we know the angle. So that's half of a 60. That one's a 30. And we've got a right angle here. So if we say that the whole of the length is an x, I'm not going to use r again, I've already used it. That means we've got half of an x here. So we could use SOHCAHTOA to find x in terms of r. We also have an x here because it's, again, a big equilateral triangle for the big hexagon. So where this one is x, this one is also x. And then this one is r, the radius of the circle. So we could use Pythagoras with half x, x and r, or SOHCAHTOA with the 30-degree angle, x and r, or half x and r, however we want to do it, but we can get x in terms of r. I'm going to use the SOHCAHTOA. So I've got my angle here. I'm going to use the adjacent and the hypotenuse. It doesn't matter which one we use. So cos 30 equals adjacent, which is r, over hypotenuse, which is x. Cos 30, we've got a calculator, but cos 30 is square root 3 over 2. So square root 3 over 2 is equal to r over x, times by x, x times square root 3 over 2 is equal to r. So x is 2 r's over square root 3, so timesing by 2, dividing by square root 3, 2 over square root 3 could also be written as 2 root 3 over 3 if we rationalise the denominator. So 2 root 3 over 3 times r. So for the big hex, the perimeter is 6 lots of x, 6x, which is 6 times 2 root 3 over 3 r, and 6 over 3 cancels to 2, so it's 4 square root 3 times the radius. So we've got the small hexagon's perimeter, the big hexagon's perimeter. By considering perimeters, show that pi is in between 3 and 2 root 3. What's the perimeter of a circle? The perimeter of a circle is the circumference, 2 pi r. So the circle circumference is equal to 2 times pi times the radius. So what about this 3? Pi is in between 3 and 2 root 3. So the circle's circumference must be in between the perimeter of the big and the small hexagon. So the small one was 6r. The circle is 2 pi r, and the big one is 4 root 3 r. If we divide through by r, and then half everything, we get 3 pi and 2 root 3, which is what we wanted.